Welcome to ABL's Maritime Market Briefing for June 2025. Today we're going to be talking about charting a course to net zero and the IMO's first global carbon pricing mechanism. This webinar is accredited by the Chartered Insurance Institute, and delegates participating can get 1 CPD point for their scheme. So we will be sending out certificates if you want them. So please let us know afterwards. And for those of you in the room, if you signed in and you want them, then we'll also get those to you. Today's presenter, Stefano Scarpa, will be talking about the technical part of our presentation, and Colin Stevenson will be giving the case reports. Information contained in these presentations and any opinions or comments expressed are those of the presenters and not necessarily those of ABL Group or any associated companies. That's the legal bit out of the way. We really need your feedback to keep these market briefings going and keep them relevant. It also helps us maintain our CPD accreditation, which is very important. So if you can spare a few minutes today or sometime during the week to fill in the feedback, that would be very useful. The QR code is also outside on the bench for those of you in the room. And I'm now going to hand over to Stefano, who's going to lead the technical presentation. Thank you.
Thank you, Mark. Good morning, everyone, here at the Lloyd's of London and online. So today we are going to talk about the IMO Net Zero Framework that was recently approved at MEPC 83 at the IMO, so the Marine Environmental Protection Committee 83 at the IMO, a couple of months ago. It's a complex topic, I have to warn you, so I tried to simplify it as much as I could for everyone, but it's complex, so you got to really pay attention to it. I hope you're interested. Okay, so today you will learn about you will gain a clear understanding of the IMO Net Zero Framework and its objectives. You will be able to explain how the framework operates and its key mechanism. We will explore the various compliance pathways very briefly under the framework, and you will gain insight into the risk associated with net zero technology, fuels, and energy efficiency measures. You will get just a snapshot, a very high-level overview of all these things, because it's very difficult to go into depth into all these topics in half an hour. But if you want to know more, happy to discuss anytime. So, MEPC 83, Marine Environment Protection Committee. I attend all the MEPC at the IMO personally, and also the Intersessional Working Group on Greenhouse Gases, as I'm the chair of a policy working group for an industry group called the International Windship Association, which promote the interest of the wind propulsion sector in commercial shipping, which is a thing. It's not just a paper exercise, but there are ships out there nearing 100 with this system now, going up, increasing the number over the time. Okay. Let's start to talk about it. The background. This is a breakthrough agreement. It's the first ever global carbon pricing in shipping and in an industry globally whatsoever. It's a major milestone, despite the ambitions are not as high as hoped by some in the IMO. It's also a strong signal to the market to boost investment in green technology and energy efficiency. It was achieved through a vote, which is a very rare occurrence at the IMO. Normally, at IMO, decisions are taken in an anonymous way. So people, member states agree all together at resolutions. This was achieved through a vote called by one member state. 63 member states voted yes to the framework, and this was led by EU, China, India, and Brazil, and many others, of course. 16 voted no, included Saudi Arabia, Qatar, UAE, many Middle Eastern countries, Russia, Malaysia, North Korea, and a few others. 40 abstentions, mostly the Pacific Islands that were the most, that will be the most affected by climate change, and they wanted the framework to be more pushed to demand more from shipping, international shipping, and Liberia. Among the yes, we got also Panama, just to counterbalance. Abstentions don't count in the ballot counting, only yes and no. And who decided not to vote as well doesn't count. So the next step is a ratification that will happen in October. So this framework will be put for ratification in October 2025, and MEPC extraordinary session 2. This will require 2/3 of the assembly of the member states that are a signatory of the MARPOL Annex 6 to vote yes, fundamentally. According to many analysts and also our own analysis, it's very likely that the ratification will happen. And then the framework will enter into force from 2028. Okay, to which type of vessel does it apply? Big vessel, big means 5,000 gross tons or greater, and engage in international shipping. So ferries that operates domestically, small vessel at the moment are not included in the framework. Also are not included offshore vessels of any size. Anyway, this could change, and there are already states that are considering the adoption of this framework also at national level, and for vessel of 400 gross tons and over, so a bit smaller, between 400 and 5,000, not only 5,000. These states are Scandinavian countries, the UK as well, Brazil, some other. There are a few around the world that are making this consideration right now. Okay, now we get into the thick of it, which is complex. Okay, so it's a compromise system which blend a greenhouse gases fuel intensity standard, and I will try to explain what that is, with a 2-tiers economic measure. Economic measure means that you have to pay some money if you emit greenhouse gases emission. Greenhouse gases emission fuel intensity is the amount of greenhouse gases that a fuel or an energy, because it's not only fuel, produce divided by the energy of that fuel, that fuel or energy deliver to a vessel. I will explain that in a minute. So the reference to the framework is the 2008 average greenhouse gases fuel intensity, which is 93.3 grams of CO2 equivalent per megajoule. So these are measures of carbon mass, carbon emission mass, grams of CO2 equivalent. Megajoule is a measure of energy, and it will be well to weight. So all this is a bit of lingo that I'm trying to explain now. The target, there are two tiers, economic tiers, so 2 targets, a baseline target and a direct compliance targets that create surplus and remedial units. Okay, so let's talk about energy from fuel. I use this as an analogy, a car. You put fuel in a car, the fuel ignite into a diesel or a petrol engine and move the car. So the motion of the car is given by the energy of the fuel that goes from chemical energy in the fuel into heat, which is a form of energy, and mechanical energy. And then the car moves, but the fuel has been burned, and the gas, the exhaust gases, contain carbon dioxide, which is a greenhouse gas. So it's the most important greenhouse gas. So imagine that this happens also on ships. And not only for the ship's movement, but also for the operation of all the ship system. You need to use energy. Now, the framework doesn't apply only to fuel, but also to other form of energy. What could they be? So one that can be applied today and is applied today is wind propulsion. So wind propulsion is the wind energy is transformed into thrust, and therefore the energy that push the vessel by a sailing system. So that's another way to convert the energy from the mechanical energy of the wind into a movement of the vessel. And this energy doesn't have any emission, is zero emission attached to it. And electricity that is used in vessels, so domestic vessels, for example, electric vessels, is also another form of energy and doesn't have emissions, but it does. So it doesn't have emissions when you propel the vessel, but it does before, and that's the well to wake. So we got the time to wake is, for example, is the emissions that you have in the vessel or in the car. You burn that fuel and you get on the tailpipe, you get some emissions. That's the time to wake emissions. The well to tank is the emissions that are emitted when there is the production of that fuel. Okay, so when a fuel is produced, it needs to be transported. So there are trucks or ships that transport it, and there are emissions related to that and other processes to crack the oil, for example, into petrol or diesel. And for electricity is the same. The production of electricity produce well to tank emissions. There is no tailpipe emissions then. So the well to tank is something in electricity. The time to wake is zero. So I don't know if I explained that properly. So going back to this, greenhouse gases fuel intensity is the emissions from the energy produced by a fuel or an energy. Well to wake from the extraction to the tailpipe. Okay. This is the framework, how it looks like. It's quite complex, but look at three things here. The two gray lines are the compliance lines. Okay, then we have the green lines is the near zero technologies line, and then the IMO net zero fund, that little house up there. So on the horizontal axis, we have time, and on the vertical axis, we have emission intensity. In 2028, the reference point is on the vertical axis, is there 93.3 grams per megajoule. So if a ship doesn't emit a lot, is low. If it emits a lot, is high into this diagram. So if it doesn't emit a lot, you got a green ship, and that means that you don't pay anything into this scheme. Actually, you accumulate surplus fuel because you are emitting less than what you are allowed to. Tons of CO2 that you don't need to emit. If you are like a darker green vessel, you are between the tier compliance target and the base target. So you have a deficit of tier 1. So you will have to pay some money. But if you don't comply with the base target, then you will have to pay also a tier 2 deficit. That is much, so you will have to pay the tier 2 deficit, which is much more. And we will see later how much. So the money from international shipping will be collected as a remedial unit paid by the emitters if they emit, and put into this IMO net zero fund. And the fund will be used to pay for zero and near zero technologies that the ship owner use. So if a ship owner use a wind propulsion system, which has zero emissions, then there will be some money going to him. If he's using a biofuel or an e-fuel that is within that line, there will be some money going to that ship owners. The line is stepwise, and it becomes more stringent over time. So this is the framework in a few words. These are the numbers that represent how the targets will get lower over time. Targets are defined until 2035. In 2032, the assembly needs to define the target up to 2040. The surplus units, if you comply with both compliance line, so base and direct line, you accumulate surplus unit as a ships, and they can be transferred to other vessels for compliance. So they can be sold or given if you are in the same pool. Or they can be banked from earlier year. You can bank for 2 years. Okay. The remedial units can be bought by others that have surplus units, but only the tier 2 units can be bought by others. The tier 1 have to be bought by the fund, and you can also buy from the fund. And there are some pricing there. $100 per tons of CO2 emitted. Tier 1 price of remedial unit, and tier 2 is $380. The tier 2 units, both from another ship owners, will likely not to be at $380. They will be at a lower price, which will be the marginal cost of the cheapest technology, for example, biofuel, if that's the cheapest. Okay, so then we talk about the net zero fund. The first things that it will do is to distribute the money from this system to green technologies, but also it will be used for a bunch of other stuff that you can see listed there: investment in innovation, building infrastructure for decarbonization and climate change, support people, mainly seafarer, their training, and other things that they could need, share knowledge, technologies, transfer, training, implementation tools of the technology, strengthen national plans, so help states to develop national plans that have the aim to define how to decarbonize their maritime industry and protect vulnerable states. Now, how this money will be allocated is not decided yet. It's something that is in process. There are 14 guidelines that needs to be developed from anew in order to make the whole framework working. Okay, let's going through some example now. So these green lines that you see, the two on the top and the lower one that you see on the bottom, are the lines that I showed before. So the two lines up there are the compliance lines, so the base compliance and the direct compliance line, and this lower one is the near zero and zero technology definition line. We started 2028. The other lines show what's happening if you are using, okay, there are different type of fuels. So you don't see what is written on the top line, but it's marine diesel oil, marine gas oil. So if you are using marine gas oil, you don't comply with anything. If you are using LNG, you comply with the baseline, but not with the direct line of compliance. And so you still have to pay some money, but not maybe too much. But then after a certain point, after 2032, you don't comply with the baseline either. Now, if you are using a full bio LNG or full biofuel, 100% this product in your vessel, then you can see the purple line or the near black line here. You are complying with everything until a certain point. We have to remember there is no definition of the direct compliance. Until from 2035, so we don't know how it will be. But if it follows the same trend as the baseline, there should be compliance for a long time. And then if you hypothetically are using pure wind, you comply with everything. So if you are sailing ships, which obviously we don't have, and ammonia is also ammonia is also a way to comply. So there are various ways to comply. Then we can mix all these things. So let's say we use marine gas oil and shore electricity on all stops that we do, then the carbon intensity goes down. There is a bit of better compliance. Again, shore electricity with LNG, the green darker line over there. If I'm using wind-assisted propulsion with a 15% of power delivered by the wind, we got that light blue line on top with some compliance and marine gas oil as well. If ships use a wind propulsion system for 50% of their propulsion load, there is a lot of compliance and so forth. Okay, so let's see what's happening to a bulk carrier. Andy Max, I just generated a few scenarios with a simplified model. So let's look at the BAU, business as usual scenario. So the vessel uses marine gas oil and doesn't do anything. The cost of fuel today is a bit over $5 million, and it creep up. In 2035, it become almost double. If we use biofuel to comply, so a mix of biofuel and marine gas oil together, we can achieve compliance, of course, but the cost, you can see, is even higher at the beginning, and then it starts to go down. So until 2031, it seems that it's more expensive to comply than not, and then it becomes more expensive not to comply. If the owner decides to install a wind-assisted propulsion system that provides 15% of the propulsive load, we can see that these costs go down because you have to use less biofuel. And then if efficiency measures are taken, like just-in-time arrival, biofouling management, speed optimization, weather routing, together with a wind-assisted propulsion system, we can also go much lower. Now, if we compare the full biofuel solution with a solution that includes also wind-assisted propulsion and energy efficiency, we can see that we are not spending as much, of course, and we are making less money, even less money than the business as usual case. So that certainly can pay for a wind-assisted propulsion system, this amount of money. So it's possible to comply in a sustainable way. I just wanted to show that in graphic terms. So the business as usual case, the fuel, by the way, I didn't escalate the fuel price. The price model for the fuel is very simple. I assume the price is the same all the time, which is not true. I know that, but because we are focusing on understanding the model, I didn't change that. The blue lines show the cost of compliance in a business as usual case, and you can see it goes almost double. And this is the example of, just let me turn this off. This is the example of the last scenarios where we use energy efficiency and wind-assisted propulsion, so much lower cost. So there are many things that can be done for compliance. One of them is energy efficiency, and depending from the type of vessel and the situation, the ship owners, some actions are operational, so strategy energy management system implementation, which is a management system that look into how to be more efficient and is as demonstrated to play wonders in terms of reducing fuel consumption. Biofouling management, speed optimization, weather routing, especially if it's together with wind propulsion or wind-assisted propulsion, and just-in-time or practical just-in-time arrival. And then we got technologies, air lubrication, heat recovery, hydrodynamic optimization, hybrid vessels, and power management system optimization that apply to vessels that are already diesel electric. And then training. Training is very important because it helps to enable all these other things that we can do. The other things is to use, of course, alternative energies and fuels, because with efficiency, you just reduce your fuel consumption, but you can't fully decarbonize, but you can do a lot. Alternative energies and fuel, we got three mostly. wind propulsion, alternative fuels, which is hydrogen, ammonia, various biofuel, bio-LNG, and shore power, electricity. Now, if we were looking at domestic transportation, I would have put here also full electric vessels, because it's they can be used in many situations domestically, but not in international shipping. And then data collection and monitoring, data analysis. Well, you are not decarbonizing with that, you would say, which is true, but they are essential in order to understand if you are going somewhere with all these measures. So you need really to think about data. Also, that is very important for insurance to understand eventually if things are working. Okay, so we can comply. Compliance is possible to this framework, but the big question is what to use to comply, what measures to adopt, what technologies, when to implement them, and how to do it, how to get the money to finance this capital expenditure, if there are any, and how to change the strategy of operating the business. Sometimes is necessary. Ships will look different in the future, maybe not like this, but these are examples of ships that are already out there with wind propulsion systems. In some cases, in order to see the differences, you will have to go inside the vessel. But they are already starting to look different. These are not computer images generated thing. They are real vessels sailing out there. Okay, so looking at this, we got new technology in general for all these measures that can be adopted. New technologies means uncertainty, no lack of data. New technology also are developing with different paces. Regulation are still evolving. So this framework, as you see, is approved but not ratified. So, and there are other regulation in the brew, in the UK, in other places. Crew not fully prepared because obviously technologies are novel, rules are new, and there are no certification standards. And the global support for these technologies and system is simply not there in most cases. So repairing, maintenance network around the world, it needs to be developed and built through training and agreements by the suppliers. So all these things means that there are more risk. So the risk needs to be assessed very, very thoroughly. I think with the specialists that can assist underwriter to assess the risk. There is potential for more liability cases, crew harm, fire, explosion, and environmental breach. I prepared a few slides on potential risk of the fuels and the technologies, but let's just go through a couple of those. Ammonia, for example. Ammonia is the talk of the town, especially in the UK, so the fuel of the future. However, there are many problems with ammonia. It's toxic, corrosive, explosive in enclosed spaces. So there are crew health risk, port liability, environmental damage risk. Hydrogen is not really the talk of the town, but people are still talking about it, and there are a couple of vessels with it, also yachts. Highly flammable, prone to undetected leaks, and cryogenic. I mean, the level of insulation and system to keep it liquid is incredible. So explosion, fire risk, tank integrity, bunkering incidents, those are the things that we have to look at. And then we have others. Carbon capture and storage, I didn't talk about that before, but that's because it's not included in the framework. It's not a way to comply, but maybe it will be included in the future. But here again, we have some risk, mostly because we need pressurized carbon dioxide tanks that are refrigerated. So all these systems are at a very low temperature, and they could fail. So, and carbon dioxide is not toxic, but remove the oxygen from the air from a space, so you can be asphyxiated, and it can kill you because you don't detect it. It can kill you very easily. So there are risks there too. And then I just touch on one of these. Operational measures are great because they don't cost a lot of money, but they need to be done properly. And there is some risk on that. For example, slow steaming, which is part of speed optimization. A risk is on the engines of prolonged low load operation that can harm the engines. Delays can impact emergency responsiveness because you're going slow. So increased wear, off-hire claims, engine underperformance risks, etc. And then there are others, but I'm not going to go through all of them. And so this is the last slide. So it's about recommendations. So this is my recommendations: strengthening risk and underwriting rules. So assess the fuel type and technology maturity, possibly in conjunction with some independent expert. Scrutinize high-risk technology, specifically hydrogen, ammonia, carbon capture and storage, carbon capture on board. And there are various ways to deal with that from an insurance point of view now, but you know it better than me. Risk-adjusted premiums and exclusion is one of them. Training and certification of the crew. Now, the problem is that there is no certification of just coming up a few for some of the alternative fuels. Request those certifications where they are available and make sure that they are checked. And then training, even if the certification is not there, should be enforced. And require robust support plans. So if a vessel has a technology, there should be a maintenance plans and an emergency plan with people that can really repair and maintain around the world, so around the routes of the vessel. Work with class technology provider and independent consultants to assess the risk jointly. There are various groups that do that. Now we have recently entered into an activity with the University of Strathclyde and other partners to assess the risk of technologies and fuels related to decarbonization, but there are other groups and panels. Use third-party independent audits for confidence, track regulation and claim trends, and use pilot and conditional coverage. So in other words, maybe do some tests with a vessel or another, increasing maybe the deductible. And so that's essentially it. So with this, we now close the part of the webinar with the technical presentation. Now we are. Oh yeah, sorry. Sorry. Any question? Yes.
How do they propose to actually police the financial aspects?
Yeah, that's a very good question. Police, meaning.
I was just asking about the financial aspects and how they collect and manage the funds policing.
The policing is not defined yet, but the collection of the money is through the flag administration of the member states. They will collect the money. There will be a system that is based on the data collection system that has been expanded to include more data. Data collection is about fuel consumption. So it will be expanded to energy use. And so that system is in place for the CII. So it will be the backbone of the compliance verification system, how we want to call it, check compliance. And then the money collection will be done by member states, and then they will go into this fund. And what is defined is who should be on the board of this fund, how the fund will be managed by the IMO, but the details of compliance and verification is one of the guidelines, or more than one of the guidelines that needs to be developed. Thank you. Aurelia.
Thank you, Stefano. Very good presentation. I have a question. How the ship owners was a fleet is going to be moving up by by ship?
Okay.
If I have, let's say, 10 ships, 5 are in compliance, 5 not in compliance, does the ship owner need to pay stricter money, considering how the ships are designed?
Okay. So thank you for the question, Aureliano. If 5 ships that are compliant and that's it, and 5 that are not compliant, the ship owner will have to pay remedial unit for the ships that are not compliant. If the compliant ships are over compliance, so they produce surplus units, those can be transferred to the ships that are not compliant and potentially make them compliant. So hypothetically, a ship owner could have a ships that is primary wind propelled, so 50% of the load is from wind propulsion. These ships is going to generate surplus unit, and then he can transfer them to the other vessel.
So he doesn't need to go via the island, he can transfer directly?
Yes, he can. If the non-compliance is a direct non-compliance, yes. If it's base non-compliance, no, he will have. So the lower number, so let's say the base compliance is the less stringent target. If you are not complying even with that, then there is no choice. You have to buy the remedial unit from the fund. You're welcome. Yeah, all right. Thank you. That's it with the question. Thank you for your question. So now Colin will give you the case report. Thank you.
That's the end of our online presentation. Thanks everybody for joining online.